So we need to find the values of each of the following problems. So let's begin with part 1. So here we are given 3 raised to the power of negative half multiplied to log of 81 with a base of 3. What we'll do, we'll start with the power part, which is negative half times log of 81 with a base of 3. We can rewrite it as, we're going to use a property. Let's say if we have log a times log of b, that was equivalent to log of b raised to the power of a. Using this property, we will have 3 raised to the power of log of 81. Now we will raise the power of 81 as negative half with a base of 3. Right. Why we have done it? The reason behind this is, so whenever we have a raised to the power of log of b with the base a, then this is equals to b. That means the base of the exponent and the base of the logarithm, if they are the same, then this value will be equals to b. Right. So in our case, the base of the exponent is 3 and the base of the logarithm is 3. So that means this will be equals to 81 raised to the power of negative half. So that's the answer. We can further simplify it. So 81 is 9 squared. So we have 9 squared raised to the power of negative half, which will be simply equals to 9 raised to the power of 2 multiplied to negative half. So this is a property of indices. So here what we'll do, we have a raised to the power of b whole raised to the power of c. That's equivalent to a raised to the power of b times c. Now the 2 and 2 gets cancelled out, and that leaves us with 9 raised to the power of negative 1, or simply 1 over 9. So this is the value of the following one, which is 3 raised to the power of negative half times log of 81 with a base of 3. Now let's find out the value of part 2, which is 2 raised to the power of log of 15 with a base of 2 square root of 2. To solve this particular problem, we'll use this property. However, there is an issue here. If we look at the base of our logarithms, so that's 2 times square root of 2, whereas the base of the exponent is 2. So they are not matching. But we know that if we have 2 times square root of 2, if we square it, then this value is equals to 8. Now what's 8? 8 is 2 cubed. So that means 2 times square root of 2 whole square is equals to 2 cubed. Now we'll take cube root on both sides. That gives us 2 times square root of 2 square. We'll take the cube root, and this gives us 2. So that means in place of 2, we can write 2 times square root of 2 whole raised to the power of 2 third. So this is what we have written here in terms of exponent form, 2 times square root of 2 raised to the power of 2 thirds. So we'll replace this 2 with this value. So that means we have 2 square root of 2 raised to the power of 2 third multiplied to log of 15 with a base of 2 root 2. Now we will use this particular property to raise 15 with the power of 2 over 3. So we have 2 times square root of 2 whole raised to the power of log of 15. Now 15 will be raised to the power of 2 third with a base of 2 root 2. So now we are okay to apply this particular property because the base of the exponent and the base of the logarithm are exactly the same. So this gives us 15 raised to the power of 2 over 3. So this is the value of 2 raised to the power of log of 15 with a base of 2 root 2. Now let's move on to the third problem. Problem number 3. Here we have 7.5 raised to the power of log of 10 with a base of 7.5, and this is added to 1. Now what we'll do here, we'll use a definition of logarithm. That means whenever we have log of a to the base of a, that value is equals to 1. So that means we can replace this 1 with log of 7.5 with a base of 7.5. This will become evident in the moment why we're using this particular value. So this will be 7.5 raised to the power of log of 10 with the base 7.5. So the plus instead of 1, now we were substituting with log of 7.5 with the base of 7.5. The only reason we're doing this because now we can combine these two logarithms. They have the same base with our property. And if we have log of a added to log of b, that will be equals to log of a times b. So this gives us 7.5 raised to the power of log of 10 multiplied to 7.5 with a base of 7.5. So that means we have 7.5 raised to the power of log of 75 with a base of 7.5. Now we can apply this particular property of logarithm because the base of the exponent and the base of the logarithm are exactly the same. So this will be equals to 75. So this is the value of part 3. Now let's move on to part 4. So here we have a raised to the power of log of m, the base of a, plus log of n, the base of a, plus log of p, with the base of a. So we can combine these three logarithms using this particular property. So we have a raised to the power of log of m and p with the base of a. Then we use this particular property to get m and p. So here we have log of base 5 of 10 0.25 pi, which will be log 10. 0.25 is 1/4 or 1/4, so that will be pi over 4 with a base of pi. So that's equals to log with a base of pi. What's the value of 10 pi over 4? So that value is always 1. Now, log of 1, regardless of whatever base we have, it really doesn't matter. So whenever we have log of 1, the value is always equals to 0. So that means the value of log of 10 0.25 pi with a base of pi, this value will be equals to 0. Let's move on to the 6th problem. So here we have to find out the value of log with a base 2 of log of 81 with base 3. Right. So we have log of 2, log of 81. So since we have a base of 3, 81 can be expressed as 3 raised to the power of 4. This will mean exactly the same thing. Now 3 raised to the power of 4, we have log of 3 raised to the power of 4, which we can rewrite using this particular property. So that will be log of 2 will times 4 times log of 3 with a base of 3. Fine. Now we'll use this property. A value is 3, so that means log of 3 with a base of 3, this goes to 1. So we are now left with log of 4 with a base of 2. Now 4 can be written in terms of 2 as log of 2 squared with a base of 2. So that will be 2 times log of 2 with a base of 2. So this goes to 1. So that means we have 2 times 1, which will be equals to 2. So this is the value of log 81 base 3 with a base of 2. Now that's equals to simply 2. Let's move on to the final problem, part 7. Problem number 7. So here we have log of 5 with a base 3, and it's multiplied to log of 27 with a base of 25. So here we're going to use a property of logarithm. Whenever we have log of a with a base of b, that's equals to log of a, let's say we take the base c, divided by log of b with a base of c. So that means we can rewrite our logarithm for log of 5 with a base of 3 as log of 5 divided by log of 3. Let's consider the base to be 10 for simplicity. This will be multiplied to log of 27 with a base of 25. So that will be log of 27 with a base of 10 divided by log of 25 with a base of 10. Right. So that will be log of 5. So we'll drop the base. That will be divided by log of 3 multiplied to log of 27. So 27 is 3 cubed divided by log of 25. So that's 5 squared. We can use this particular property to get log of 5 divided by log of 3 multiplied to 3 times log of 3 divided by 2 times log of 5. So here log of 5, log of 5, log of 3, and log of 3 cancels out, and this leaves us with 3 over 2. So this is the value, final value of log of 5 with a base of 3 multiplied to log of 27 with a base of 25.